Look up on a clear night, and instead of stars, you'd see a glowing arch slicing the sky in half, bright enough to read by, changing shape with the seasons. That's not fantasy. Earth almost certainly had rings before, and the physics says it could happen again. Here's the mystery. Every large planet in our solar system except Earth and Venus has rings right now. Jupiter, Saturn, Uranus, Neptune, all ringed, so why not us? The answer isn't that Earth is special. It's that rings are temporary, and we may simply be between sets. Rings form in a narrow zone called the Roche limit, the distance from a planet where its gravity would tear apart any moon or asteroid that wanders too close. Tidal forces stretch the object until it shatters into billions of icy or rocky fragments. For Earth, that limit sits roughly 9,500 kilometers from our center, just outside the atmosphere. In 2024, geologists proposed exactly this happened 466 million years ago. An asteroid strayed inside that limit, broke apart, and for a few million years Earth wore a ring of debris before gravity slowly rained it back down as meteorites. That period matches an unusual spike in impact craters, all clustered near the equator, exactly where ring material would fall. So picture the version we lost, or the version we might gain. A ring built from a shattered small moon or captured asteroid would settle into Earth's equatorial plane, the same plane the moon roughly follows. From the ground, it wouldn't look like a solid disk. It would look like a luminous band stretching from horizon to horizon, brightest near local noon and midnight, catching sunlight like a permanent, silver rainbow with no color, just brilliant, reflected white. But the actual experience would depend entirely on latitude, and this is where things get strange. Stand at the equator and the ring would appear edge-on, a thin, brilliant line slicing straight overhead because you're looking at it from within its own plane. Travel toward the poles, and the ring tilts wider, curving up from the horizon like a frozen rainbow. Past a certain latitude, roughly where the ring's shadow falls, you'd lose the ring entirely for parts of the year. It would dip below the horizon, hidden by the curve of the Earth itself. Now add the tilt. Earth spins on a 23.5-degree axis, and any ring would inherit that same tilt relative to the sun. That means during our summer and winter, the ring would cast a colossal shadow across entire hemispheres. Saturn shows us this already. Its rings periodically block enough sunlight to cool the upper atmosphere in the shadowed band by measurable amounts. Scale that to Earth, and you get regions plunged into a dim, ring-shadowed twilight for months, then bathed in reflected ring light during the opposite season, an entirely new climate variable layered on top of the one we already have. That shadow would do more than dim the sky. It would very likely reshape weather patterns. A band of reduced sunlight moving with the seasons could alter temperature gradients, shift jet streams, and change rainfall distribution, the same way volcanic ash clouds or aerosol layers measurably cool regions today. Some researchers modeling ring scenarios suggest seasonal ring shadowing could shave off several degrees of surface temperature in affected zones, enough to disrupt agriculture, monsoon timing, even ocean currents that depend on temperature difference to drive circulation. Then there's the sky show closer to home. Ring particles aren't perfectly stable. Atmospheric drag, solar radiation pressure, and gravitational tugs from the moon would slowly erode the ring, sending a continuous drizzle of micrometeorites into the upper atmosphere. Saturn's rings are estimated to lose enough material that they may fully disappear within 100 to 300 million years, raining down as ionized gas that literally darkens parts of its upper atmosphere, an effect scientists call ring rain, confirmed by Cassini's final plunge in 2017. Earth's version would mean constant, dazzling meteor streaks, a nightly fireworks show, but also a slow accumulation of dust settling everywhere, an ongoing cosmic snowfall too fine to notice day to day but never fully stopping. Would it affect satellites and space travel? Almost certainly. Anything orbiting within the ring's radius, roughly matching where many of our satellites and even the International Space Station operate, would face constant sandblasting from ring debris. Launch trajectories would need to be threaded carefully to avoid the debris band entirely, the same way real spacecraft today plan flybys of Saturn to dodge its ring plane. Getting to orbit could become an exercise in aiming through gaps, not unlike Cassini's engineers plotting a needle's path between Saturn and its innermost ring in 2017. Culturally, imagine the effect on human history. A visible ring would have anchored calendars for every civilization on Earth. Its tilt relative to the sun changes, with the seasons the way Saturn's rings appear to open and close over a 29-year cycle when viewed from Earth. Our own ring would open wide in one season and thin to nearly invisible in another, a built-in celestial calendar bright enough to set agricultural and religious cycles around, long before anyone invented a clock. So why doesn't Earth have this now, when the physics clearly allows it? Timing. Rings need a fresh source of debris, either a captured object or a shattered moon, and enough time has to pass since the last event for us to be caught empty-handed. That 2024 study suggests we simply had ours already, 466 million years ago, and it's long since fallen from the sky as those equatorial craters and dust layers found in ancient limestone. Every ring eventually falls, and every ring, given enough capture events over geological time, eventually returns. So the real answer isn't science fiction. It's timing. Earth is a planet between rings, not a planet without them. Somewhere out past our orbit right now, there could be a small asteroid on a slow, silent path that will one day cross that invisible Roche limit line, shatter, and hand our descendants a sky none of us have ever seen, one already written faintly into the rock beneath our feet. The question isn't whether Earth could wear a ring again. It's simply when the next one starts falling into place.